Hey everyone, it's Klepik back again with another deep dive into baghouses. Today, we're going to walk through the 7 key steps for calculating your baghouse system. Whether you're designing a new setup or upgrading an existing one, getting the calculations right is crucial. So let's jump into the methodology, an example, and a rough cost estimate. Step 1. Determine the airflow. The first step in calculating your baghouse is figuring out the airflow you'll need. This is typically measured in cubic feet per minute, CFM. Your airflow will depend on the volume of dust your operation generates, the size of the area you're filtering, and the type of dust you're dealing with. A good rule of thumb is to start by analyzing the amount of air needed for each dust collection point in your facility. Add up the air requirements for each area, and that will give you the total CFM. The more dust your system needs to filter, the higher the CFM, so you'll need to make sure your baghouse can handle that volume. For example, if you're filtering air from a metalworking facility and estimate the CFM requirement to be 10,000, you'll use that number for the next steps. Step 2. Calculate the air-to-cloth ratio. Next up, we need to calculate the air-to-cloth ratio. This is the relationship between the amount of air passing through the system and the surface area of the filter media, the cloth. A good air-to-cloth ratio ensures that your filters aren't overworked, which can reduce efficiency or lead to clogging. For most baghouse applications, an air-to-cloth ratio of 3.1 to 5.1 is typical, but this can vary depending on the type of dust and the operating environment. For instance, fine dust might require a lower ratio, like 3:1, while coarser particles could allow for a higher ratio, around 5:1. Step 3. Select the filter media. Choosing the right filter media is critical because it directly impacts how well your baghouse performs. The type of dust you're dealing with, as well as environmental conditions like temperature and humidity, will determine what kind of filter bags you need. Some of the most common filter media include polyester, great for general-purpose applications; PTFE, Teflon, ideal for high-temperature or chemically aggressive environments; aramid, Nomex, excellent for heat resistance and abrasive particles. For our example, if we're dealing with standard dust in a metalworking environment, polyester filter bags would likely do the trick. Step 4. Determine the number and size of filter bags. Now that we know how much filter area we need, we can calculate the number and size of the filter bags. Let's assume each bag is 8 inches in diameter and 10 feet long. To calculate the surface area of a single bag, use this formula. The formula will be provided below. Step 5. Calculate the housing size. With the number of filter bags determined, we can now calculate the housing size for the baghouse. The housing needs to accommodate the bags, leaving enough room for the air to flow around them and for the cleaning mechanism to function properly. Baghouses typically have a filter-to-housing ratio that gives a rough idea of how much space is required. For example, a typical ratio might be 1.2 square feet of housing per square foot of filter media. Using that ratio, we can estimate the housing size: 2,500 square feet of filter media x 1.2, 3,000 square feet of housing. That's the space you'll need for the baghouse structure. Step 6. Cleaning methodology: pulse jet, shaker, or reverse air. Next, you need to choose your cleaning method. The most common methods are pulse jet, shaker, and reverse air. Your choice of cleaning method depends on the size of your system, the type of dust, and how often the filters need cleaning. Pulse jet. This is the most efficient cleaning method. It uses compressed air to blow out dust from the filter bags, allowing for continuous operation. Shaker. The bags are shaken periodically to remove dust. This method works well for smaller operations, but requires the system to be turned off for cleaning. Reverse air. Air flows in the opposite direction to dislodge dust from the bags. This is a gentler method, making it suitable for delicate filter media. For our example, let's assume we choose a pulse jet system due to the high dust load and the need for continuous operation. Step 7. Cost estimation. Finally, let's talk cost. The cost of a baghouse system depends on several factors: size, filter media, cleaning mechanism, and installation. Here's a rough breakdown. Housing and filter bags. The housing size and the number of filter bags determine the base cost. For a system with 119 filter bags and 3,000 square feet of housing, you're looking at around $50,000 to $100,000, depending on the materials and custom features. Cleaning mechanism. A pulse jet cleaning system can add anywhere from $15,000 to $30,000 to the cost, depending on the complexity and size. Installation and maintenance. Installation costs can vary depending on your location and the complexity of your system. Expect installation to add another 15–30% to your total cost. Maintenance costs, including replacing filter bags and energy consumption, will be an ongoing expense. For our 10,000 CFM system with a pulse jet cleaning method, the total cost could land anywhere between $80,000 and $150,000. So, there you have it, the 7 key steps for calculating your baghouse system. By walking through these steps, you can ensure your baghouse is appropriately sized and tailored to your specific needs. It's all about getting the right airflow, filter media, and cleaning method to maximize efficiency and minimize costs. If you're looking to design or upgrade your baghouse, Torch Air is here to help. Reach out, and we'll guide you through every step, from choosing the filter media to cost estimation. Thanks for watching, and see you next time.